The planet before us.
66 million years ago, a rock the size of a city fell from the sky. It hit what is now Mexico, and in a matter of months, it ended the reign of the dinosaurs. The sky darkened, the oceans acidified, and nearly 3/4 of all life on Earth was wiped out. But life, stubborn, relentless, impossibly creative, survived. Hidden in the shadows of that dying world, small furry creatures had been waiting for their moment. They were warm-blooded. They nursed their young. They were flexible in ways the dinosaurs never were. They were the first mammals, and from them, eventually, came us. 2. The first primates. Around 55 to 60 million years ago, a group of these mammals began doing something new, climbing trees. It sounds simple, but that shift, life in the canopy, changed everything about how a body is built. Eyes moved to the front of the face, giving depth perception. Hands developed with fingers that could grip. Brains got bigger because navigating a three-dimensional forest, leaping from branch to branch, tracking fruit, watching for predators, all of that demands serious computing power. These were the first primates. They didn't look like us, they didn't think like us, but they were the opening chapter of our story. 3. The fork in the road. For tens of millions of years, primates diversified. Some stayed small, others grew bigger. And then, roughly 7 to 8 million years ago, something extraordinary happened. One lineage split in two. On one side, chimpanzees and bonobos, our closest living relatives. On the other, a group of apes that would eventually walk upright, make tools, paint caves, write symphonies, and launch rockets into space. That split didn't produce humans overnight. It produced a long, messy, fascinating family tree, full of cousins, dead ends, and creatures that were just almost us. Let's meet them.
4. The almost humans.
Paleoanthropology, the study of human origins, has a habit of getting stranger the more you look at it. Every few years, someone digs up a bone somewhere, and the whole family tree has to be redrawn. What we know for sure is this: between about 7 million and 2 million years ago, Africa was crawling with upright walking apes. Some were our ancestors, some were not. Most of them we've only found in fragments, a jaw here, a skull fragment there, a single fossilized tooth. But from those fragments we can piece together something remarkable. 5. Sahelanthropus chidensis, 7 million years ago. Meet the oldest known contender for member of the human family. Found in Chad in 2001, Sahelanthropus chidensis is represented mostly by a skull nicknamed Tumai, which means hope of life in the local language. And it offers exactly that, a tiny window into the very beginning of our story. The skull shows a mix of primitive and advanced features. The brain was small, about the size of a chimpanzee's, but the face was relatively flat, and the foramen magnum, the hole at the base of the skull where the spine connects, suggests it may have walked upright. May have. And that's the frustrating thing about this era. The evidence is sparse, the debates are fierce, and the truth is, we're not entirely sure where Sahelanthropus fits. Might be our direct ancestor, it might be a cousin, might even be more closely related to chimpanzees than to us. But it walked the earth at exactly the right time to be the starting gun of the human race. 6. Ardipithecus, 4 million years ago. By 4.4 million years ago, things get a little clearer. Enter Ardipithecus ramidus, or just Ardi to her friends. Discovered in Ethiopia in the 1990s, Ardi gave scientists something they had never had before, a nearly complete skeleton from this period, and what they found upended decades of assumptions. Scientists had long assumed that our earliest ancestors were knuckle walkers. like chimps today. Ardi proved that wrong. She walked upright on the ground, but she also had grasping feet perfect for climbing trees. She was a creature of two worlds, the canopy and the forest floor. Her brain was small, her teeth suggested an omnivorous diet. She was not impressive by modern standards, but she was doing something no chimpanzee would ever do, occasionally standing tall, looking out across the landscape and walking forward on two legs. That moment, however tentative, was the beginning of everything.
7. Australopithecus, the star of the family tree.
Now we get to the genus that most people have actually heard of, thanks to one famous individual. In 1974, in the Afar region of Ethiopia, a team of scientists discovered the partial skeleton of a small female hominin. They were playing Lucy in the Sky with diamonds in camp that night. They named her Lucy. Lucy was an Australopithecus afarensis, and she lived about 3.2 million years ago. She stood roughly 1 meter 20 tall. Her brain was small, about a third the size of ours. But her knee joint was unmistakable. She walked upright like us. Lucy became one of the most famous fossils ever found. But she was just one of many Australopithecines, a whole genus of upright walking small-brained hominins that dominated Africa for over 2 million years. Some were glacial, light-framed and nimble, like Lucy. Others were robust, with massive jaws and teeth capable of grinding tough vegetation, like Paranthropus boisei, sometimes called Nutcracker Man. The Australopithecines used basic tools, lived in social groups, and spread across much of Africa. They were not human, but they were practicing the moves that would make humanity possible.
8. Enter the genus Homo.
About 2.8 to 2 million years ago, something shifted. The climate changed, Africa got drier, forests shrank, grasslands expanded, and some populations of hominins responded by getting smarter. We see it in the fossils, skulls with larger brain cases, and we see it in the archaeological record, stone tools. Welcome to the genus Homo.
9. Homo habilis, the handyman.
Homo habilis, handyman, appeared roughly 2.4 million years ago, and the name fits. Alongside habilis fossils, scientists found the oldest known stone tools, called the Oldowan industry. Rocks deliberately struck against other rocks to produce sharp edges. It sounds trivial, it was not. Making a stone tool is not instinctive. It requires planning, fine motor control, and the ability to imagine an end result before you've achieved it. It requires, in short, a kind of thinking that no animal before habilis had demonstrated. Habilis was still small, still ape-like in many ways, long arms, a relatively small brain. But something was happening inside that skull. Something new. Something that, over the next 2 million years, would change the planet forever. 10. Homo erectus, the first explorer. If habilis was the prototype, Homo erectus was the first finished model. Appearing around 1.9 million years ago, erectus was the first hominin that would look genuinely human to modern eyes. It was tall and up to 1.8 meters. It had a significantly larger brain than its predecessors. It made better tools. The Acheulean hand axe, a teardrop-shaped blade that required real skill to produce. But the most remarkable thing about erectus wasn't what it made. It was where it went. Homo erectus was the first hominin to leave Africa. By 1.8 million years ago, erectus populations had reached the Caucasus, modern Georgia. By 1.7 million years, they were in China and Southeast Asia. They spread across a vast portion of the Old World and survived, in some populations, until as recently as 100,000 years ago. And somewhere along the way, erectus did something that changed the world more than any tool ever could. It tamed fire. The control of fire is almost impossible to overstate. Fire meant warmth in cold climates. It meant light after dark. It meant protection from predators. And it meant cooking, which softened food, made it easier to digest, and may have helped fuel the explosive growth of the hominin brain. Homo erectus didn't just survive, it thrived, and it laid the groundwork for every species that came after.
11 Homo heidelbergensis, or the forgotten ancestor.
Around 700,000 years ago, a new species emerged in Africa and Europe, Homo heidelbergensis. Heidelbergensis is often called the forgotten ancestor because it sits in an awkward middle position, too advanced to be erectus, not quite modern enough to be Sapiens or Neanderthal, but this species deserves more attention than it gets. Heidelbergensis had a brain approaching modern human size. It built shelters. It hunted large game cooperatively. Some evidence suggests it may have used wooden spears. It was, in a word, formidable. And it was the common ancestor of two lineages that would both, in different ways, come to define the later Ice Age world: the Neanderthals in Europe and Western Asia, and Homo sapiens in Africa. 12 are cousins who almost won. For a long time, Neanderthals were the punchline of human evolution. Brutish, dim-witted, the evolutionary losers who couldn't compete when clever modern humans showed up. That story is wrong, almost entirely wrong. And over the past 2 decades, science has completely rehabilitated the Neanderthal reputation. 13 Neanderthals, smarter than we thought. Neanderthals evolved in Europe and Western Asia beginning around 400,000 years ago. They were built for the cold, stocky bodies, large noses to warm frigid air, wide faces. They were physically powerful, more muscular than modern humans, with bones that show the wear of a life of intense physical labor. Their brains were on average as large as ours, or even slightly larger. Neanderthals made sophisticated tools, the Mousterian industry, more refined than anything that came before. They buried their dead, sometimes with what appear to be grave goods. They cared for their injured and their elderly. We've found fossils of individuals who survived serious injuries for years, meaning they were supported by their communities. Recent research suggests they made jewelry from eagle talons and shells. Some cave art in Spain, once attributed to modern humans, may actually have been made by Neanderthals, predating the arrival of Homo sapiens in Europe by tens of thousands of years. These were not dim brutes, they were people. Different from us, yes, but people.
14. The DNA bombshell.
In 2010, a team led by geneticist Svante Pääbo did something that seemed like science fiction. They sequenced the Neanderthal genome from a 40,000-year-old bone fragment. And they found something that changed everything. People of non-African descent, Europeans, Asians, Indigenous Americans, Pacific Islanders, carry between 1% and 4% Neanderthal DNA in their genomes. We didn't just coexist with Neanderthals, we had children with them. Modern humans and Neanderthals interbred. The Neanderthals are not entirely gone. They live on in us. 15. The Denisovans, discovered from a fingertip. In 2008, archaeologists excavating Denisova Cave in Siberia found a small bone fragment. It was the tip of a finger. The bone was tiny, unimpressive, and over 50,000 years old. But when scientists extracted DNA from it, they discovered something extraordinary. This was not a Neanderthal, it was not a modern human, it was something else entirely. A previously unknown species of archaic human. They called them Denisovans. We know almost nothing about what they looked like. We have just a few bone fragments and some teeth, which were enormous, by the way, much larger than both modern human and Neanderthal teeth. Everything we know about Denisovans comes from their ancient DNA. And that DNA tells a remarkable story. Denisovans ranged across a vast territory, from Siberia all the way to Southeast Asia. They also interbred with modern humans. People from Papua New Guinea and Australia carry up to 5% Denisovan DNA. Some Tibetans carry a Denisovan gene variant, EPAS1, that helps them thrive at high altitude. A gift from ancient cousins, still useful today. 16. The others, hobbits, Naledi, and more. The more we dig, the more crowded the ancient world becomes. On the island of Flores in Indonesia, scientists found the remains of tiny hominins, barely a meter tall with brains the size of grapefruits, who lived as recently as 50,000 years ago. They called them Homo floresiensis, the press called them hobbits. They're one of the most bizarre and debated discoveries in paleoanthropology. In 2013, in a cave system near Johannesburg called the Rising Star Cave, explorer Lee Berger's team made a staggering discovery: the largest collection of hominin fossils ever found in Africa. Over 1,500 bones belonging to at least 15 individuals. A new species, Homo naledi. Naledi had a tiny brain, barely larger than Australopithecus, but it also had hands and feet that looked nearly modern, and it appears, based on the evidence, to have deliberately deposited its dead in that cave. A behavior that implies a degree of symbolic thinking we wouldn't expect from a creature with such a small brain. Homo naledi may have lived alongside Homo sapiens as recently as 230,000 years ago. We don't know yet whether they met. We don't know whether they interbred. We don't know, honestly, very much at all. And that's the thing about this era. The more we discover, the more we realize how much we don't know.
17. Homo sapiens enters the stage.
For a long time, the textbook said that modern humans, Homo sapiens, appeared in Africa around 200,000 years ago. Clean, simple, one origin point, one moment of emergence. The textbooks were wrong. 300,000 years ago, and it's complicated. In 2017, scientists announced the discovery of Homo sapiens fossils at Jebel Irhoud in Morocco, dating to approximately 300,000 years ago. This pushed back the origin of our species by nearly 100,000 years. But here's the twist. The skulls from Jebel Irhoud look almost modern. The faces are flat like ours, but the brain cases are more elongated, a shape we don't see in modern humans today. They were in transition. They were becoming us, but they weren't quite there yet. And they were in Morocco, not East Africa, which had been the assumed birthplace of our species. The emerging picture is not one clean origin point, but a mosaic. Populations of hominins across Africa, some more modern in facial structure, some more modern in brain case shape, gradually converging over hundreds of thousands of years through migration and interbreeding. We didn't pop into existence. We coalesced.
19. What made us different?
So by around 300,000 to 200,000 years ago, there were creatures that looked like us. But what about creatures that thought like us? The archaeological record tells a story of gradual and explosive cognitive development. Early sapiens made better tools. They used ochre, a red pigment, suggesting symbolic behavior. They made perforated shells that might have been beads. They engraved abstract patterns on rocks. And then, around 70,000 years ago, something seems to accelerate. We see the first undisputed evidence of complex symbolic thought: art, music, long-distance trade networks, elaborate burial practices, and projectile weapons. This period is sometimes called the Great Leap Forward, though many researchers now prefer to see it as the culmination of a long, gradual process rather than a sudden leap. 20. The Cognitive Revolution. Evolutionary biologist and historian Yuval Noah Harari calls it the cognitive revolution, the moment when Homo sapiens developed the ability to think and communicate in entirely new ways. Specifically, The ability to talk about things that don't exist. Every animal can communicate about real, immediate things. Predator here, food there, danger. But Homo sapiens could say, if we all agree that this river belongs to our tribe, then it does. Or there is a God who created the world and demands we behave in certain ways. Or if we build this and plant that, we can feed 100,000 people. Abstract concepts, shared myths, imagined realities. This capacity for collective fiction, for believing in things we can't see or touch, is arguably the single most powerful feature of the human mind. It allowed strangers to cooperate at a scale no other species has ever achieved. It built cities, religions, nations, and civilizations. It also built armies, inquisitions, and propaganda machines. But we'll get to that. 21. The Great Exodus. By around 70,000 years ago, Homo sapiens had been living in Africa for hundreds of thousands of years. And then, for reasons that are still debated, some of them left. Not all at once, not in one great wave, but in successive migrations over tens of thousands of years. Modern humans spread out of Africa and eventually reached every habitable corner of the planet. 22. Why leave? The honest answer is, we don't know for sure. Climate change may have played a role. Periods of drought in Africa might have pushed populations to look for better resources. A volcanic super-eruption around 74,000 years ago, Mount Toba in Sumatra, caused a global volcanic winter that may have dramatically reduced human populations and pushed survivors to migrate. Or perhaps it was simply the restless curiosity that seems to be hardwired into our species. Homo sapiens has always been a wanderer. 23. The roots. Genetic and archaeological evidence suggests that the main out-of-Africa migration happened roughly 60,000 to 70,000 years ago, likely through the Arabian Peninsula when sea levels were lower and the climate was more hospitable than today. From there, the spread was rapid, at least in geological terms. One branch followed the southern coastline of Asia, reaching South Asia, then Southeast Asia, then Australia. The first Australians arrived at least 65,000 years ago, a staggering feat of maritime travel, since Australia was always separated from Asia by open ocean. Another branch headed north and west into Central Asia, and from there split again, westward into Europe, northward into Siberia, and eventually, by at least 15,000 years ago, across the Bering Land Bridge into the Americas. The Americas were the last major land masses to be settled, and when humans arrived, they found a world teeming with megafauna, giant mammoths, mastodons, ground sloths the size of elephants, saber-toothed cats. Within a few thousand years of human arrival, most of these animals were extinct. Coincidence? Probably not. 24. When we met the Neanderthals. Again, as modern humans spread into Europe and Asia, they encountered the people who were already there. Neanderthals in the west, Denisovans in the east. What happened at those meetings? Everything. They traded, they fought, they learned from each other, and as the genetics makes clear, they had children together. The integration of ancient DNA from Neanderthals and Denisovans into the modern human genome is one of the most astonishing stories in biology. Some of the Neanderthal genes we carry may have helped us adapt to European climates. Some Denisovan genes help Tibetans breathe at altitude. Our ancient cousins left us gifts we still carry today. 25. The last of the others. Around 40,000 years ago, something changed. The last Neanderthals died. The Denisovans vanished. Homo floresiensis disappeared from Flores. One by one, all the other human species went extinct. And for the first time in millions of years, there was only one kind of human left. Us. 26. What happened to the Neanderthals? This is one of the most debated questions in all of paleoanthropology. The timing is suspicious. Neanderthals had survived ice ages, volcanic eruptions, and dramatic climate swings for hundreds of thousands of years. Then modern humans arrived in Europe, and within a few thousand years, they were gone. Was it genocide, competition for resources, disease, modern humans potentially bringing new pathogens that Neanderthals had no immunity to, climate change at a particularly vulnerable moment, or simply gradual assimilation, absorbed into the expanding Homo sapiens population through interbreeding until there were so few pure Neanderthals left that they ceased to exist as a distinct group? The answer is probably all of the above, in different proportions, in different places. There was no single event, no climactic confrontation. It was a slow, complicated, probably painful process, and it ended with the disappearance of people who had lived in Europe for over 300,000 years. 27. The loneliness of the last human species. Think about what that means for a moment. For the entire previous history of the genus Homo, about roughly 2 million years, multiple human species had coexisted. There was always someone else out there. Different perhaps, strange perhaps, but recognizably kin. And then, suddenly, there wasn't. The Homo sapiens who painted the caves at Altamira and Lascaux, roughly 17,000 to 20,000 years ago, were living in a world that no human had ever inhabited before. A world with only one kind of human, our world. We have been alone, in that sense, for a very long time. And some researchers speculate that this aloneness, this lack of a mirror species to compare ourselves against, may partly explain some of the more peculiar features of human psychology. Our obsession with defining us versus them. Our tendency to create outgroups. We evolved in a world full of other humans, and then they were gone, and we were left with only ourselves. 28. From hunters to world conquerors. Homo sapiens had spread across the planet. We had survived ice ages, volcanic winters, and the extinction of virtually every other large mammal we encountered. We had painted caves, carved figurines, made music, and buried our dead with flowers. But we were still fundamentally hunter-gatherers, small bands of people moving with the seasons, living off what the land provided. And then, roughly 12,000 years ago, we changed everything. Again. 29. The agricultural revolution. In multiple places, apparently independently, humans began doing something unprecedented, planting seeds and waiting. In the Fertile Crescent, modern Iraq, Syria, Turkey, wheat and barley were domesticated. In China, rice and millet. In Mesoamerica, maize. In sub-Saharan Africa, sorghum. In the Andes, potatoes and quinoa. The agricultural revolution is often described as the greatest advance in human history, and it was in terms of raw productivity. Farming could support far more people per square kilometre than hunting and gathering. It allowed the accumulation of surplus food, which allowed some people to stop farming and start doing other things, making pottery, metalworking, writing, governing, philosophizing. It gave us civilization, but it also gave us something else. Hunter-gatherers, the evidence suggests, were generally healthier than early farmers. They had more varied diets, worked fewer hours per day, and were less susceptible to infectious disease, because infectious disease spreads in dense, settled populations. Early agricultural societies show clear signs of malnutrition, stunted growth, and epidemic illness that simply didn't exist before farming. We traded health for numbers, autonomy for organization, freedom for cities. Whether that was a good trade is a question that philosophers, economists, and anthropologists are still arguing about today. 30. The body that doesn't know what year it is. Here's something worth sitting with. Your body thinks it's still the Pleistocene. Evolution is slow. The agricultural revolution happened 12,000 years ago. The Industrial Revolution 250 years ago. the digital revolution a few decades ago. From an evolutionary perspective, these are not enough time to change the fundamental architecture of the human body and brain. You crave sugar and fat because for 99% of human evolutionary history, those were rare and valuable. You startle at sudden noises because predators were real. You feel anxious in crowds because your ancient brain interprets unfamiliar faces as potential threats. You struggle to sleep when screens glow around you because your brain reads artificial light as still daytime. We are, in the most literal sense, Stone Age creatures living in a world we built but were never designed for. Much of what we call modern psychological suffering, anxiety, addiction, loneliness, dissatisfaction, may be, at least in part, the result of this mismatch. We are cavemen in spacesuits. And sometimes the spacesuit fits perfectly, and sometimes it doesn't fit at all. 31. What makes us us? So after 7 million years, after Sahelanthropus and Ardipithecus and Lucy and Homo habilis and Homo erectus and the Neanderthals and the Denisovans and the hobbits of Flores, what do we actually have? We have a creature with a 1/400 cubic centimeter brain, 3 times larger relative to body size than most mammals. A brain that can plan decades into the future, imagine scenarios that have never existed, and cooperate with millions of strangers based on shared abstract beliefs. We have a species that has, in roughly 300,000 years, gone from chipping flint on the African savanna to sequencing the genome of our extinct cousins, sending probes to the edge of the solar system, and debating the ethics of artificial intelligence. No other lineage in the history of life on Earth has done anything remotely like this. Not in pace, not in scale. We are, by any measure, the strangest thing evolution has ever produced. 32. The question we keep asking. And yet, for all our power, all our technology, all our civilization, the question that haunts us is the same one that haunted our ancestors, painting animals on cave walls by firelight. Where do we come from? Who are we? And what comes next? Those questions don't have clean answers. The fossil record is incomplete. The genetic data keeps surprising us. New species keep turning up in unexpected places at unexpected times. But the story itself, the long, improbable, violent, beautiful story of how a group of small-brained apes on the African savanna became the dominant force on this planet, is one of the most extraordinary stories ever told. And the remarkable thing is, we're still in the middle of it. 33. What comes after us? From a single-celled organism in a primordial ocean to a small primate in the canopy of an ancient forest, to Lucy walking upright across the savanna 3 million years ago, to Homo erectus staring into the first fire, to Neanderthals burying their dead, to us, here, now, watching this, asking the same questions they asked. We are the inheritors of an unbroken chain of survival, 4 billion years long. Every ancestor you've ever had, every one, lived long enough to reproduce. In a world full of predators and disease and disaster and extinction, every single one of them made it. That's not nothing, that's everything. The rise of Sapiens is not a story about the triumph of the smartest or the strongest. It's a story about persistence, adaptation, connection, and the extraordinary, terrifying, wonderful capacity of one species to look at the world and say, we can do better, we can go further, we can understand this. That impulse, that restless, insatiable curiosity is the most human thing there is. It got us out of Africa. It built our cities and our science. And wherever it takes us next, it started in the dark, millions of years ago, when something small and warm-blooded looked up at a sky full of stars and wondered,